especially movement. But I think this is the most important part.
Sure. Yeah. 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 It's easy to change the diaphragm. Like you said, it's just undo those just there. And undo that, replace the diaphragm. Yeah, it's doing a lot of work. Put it off the bolts in the back. You want to screws, one there, and just close it. Yeah, close it up. Just like, look, how much temperature is it? Right, we're up to temperature now, so can't hear it crackling anymore. The water will have dropped to the bottom of the can, so if you can a little bit of water out of there, or a bit of oil out of there, bring the water in, quite a lot of debris will come through as well. That's it. Yeah, that's good, yeah, that's great. So all the water is set up to the bottom and it'll come through. Down this up into the corner. Right, and this oil is not to be wasted. You can put that to one side. We put it into a waste oil container and put it back into the process next time that you do a batch. So what we can do now is, because the oil is nice and hot, turn the electricity off and start working with the methanol. And for safety purposes, it's safer to work with methanol without electricity in the area. These elements here are called a switch in them, for example. Every time the switch goes on and off, it produces a tiny little spark, and that spark might, or quite possibly could be, the spark which ignites any methanol that's spilled in the area. So to avoid any accident like that, it's a good idea just to pull the plug on the electrics all together and work just with the hand pump and the hand mixer. So turn it off and pull the plug. There we go. So red light's off means that it's safe to use methanol in the system. We'll move this out of the way. We've got 25 litres of methanol in this red container here. So you need the gloves on.
Is that how many? That is how many?
Yeah, it's 125.
25. You can see that on the side glass.
Yeah, you can't see it on the camera. Yeah, you can see it.
That actually makes the.
So you mix it 5 to 1.
5 to 1.
Yeah, so 5 times 25 is 125.
It's 5 litres of this methanol.
For every 5 litres of oil, it's 1 litre of methanol. So it's 125 litres in here at the moment. We divide that by 5, that gives us 25. So if you fill this up to, say the maximum you can process is 175, so you then divide that by 5, and then that will give you the maximum amount of methanol to be used. It's more time efficient to make a bigger batch. So if you make 175, it takes less time per litre of biodiesel to actually make it. We've only got enough oil here for 125 litres.
Okay. So the main cost mainly the biggest cause is methanol.
Yeah, that's right.
And that actually worked out. If this makes 175, let's say it's 35 liters of methanol,
Yeah.
makes it 175 of this vegetable oil,
Yeah.
and that equals 210 liters
Yeah.
biodiesel.
Yeah. Well, in the mixture, we'll be taking off a certain amount of glycerol, byproduct. So pretty much for every litre of methanol you contain, pull out a litre of glycerol. It doesn't work always the same.
Okay.
But,
So we work out nearly about 200 or less than that?
no, the actual yield that you'll get on a machine like this is about 95%. So if you put in 175 litres of oil, you'll get, should get 160 litres of biodiesel or 150 litres in the worst case scenario. So we can't just pour that methanol into the tank like we did in this tank. If we start, this tank's an open tank at the top, and that one's, as you can see, it's all a closed unit, except for the funnel at the top. There's a valve on that. And for safety purposes, you can't, certainly wouldn't want to breathe in the fumes from that methanol. So you can't just pour methanol into a bucket or into a tank, just like as you can vegetable oil. For vegetable oil, you can breathe in vegetable oil fumes, if there were any fumes. It doesn't harm you at all, but the methanol is poisonous, so you mustn't breathe in the fumes from methanol. So what we do is we use this hand pump here to suck the methanol out of this drum by putting the suction pipe in through the top here. So if you undo that, connect these two pipes together here. We're also in quite a large barn here. We've got a big open door over there. If you just swing the camera around over to there, we've got a big open door. We've got lots of ventilation up here. All these windows are open, so there's lots of free air moving about. Because even from this container here, you will get a small amount of methanol vapour coming out of there, very small, and that will be dissipated by the ambient ventilation in this area. It's important not to try and do this process in a small shed, for example. So if you move the processor somewhere else, make sure that there's plenty of ventilation. You might have to have extractor fans in the wall, moving air, making sure that there's air circulation. And if it gets cold, don't be tempted to close all the windows and the doors. It'd be better to put more clothing on rather than close the doors and stop the ventilation.
Okay.
So again, check that the valves are closed first. Yeah, so they're closed on there, closed, and then look from where you're pumping from, and then open the valves in sequence. That's it. That's it. Yeah, that's it.
Let's check.
Check. Yeah.
Check. Okay.
Right, and then slowly, carefully pump the methanol across. There's a bit of vegetable oil going through there, because the pipe's contaminated, that won't hurt it. The reason why we're doing it slowly to start with is just in case we had forgotten to close a valve. If we had made a mistake, it's better to do it slowly than quickly. Fine. Just look like it was open from where I was standing. As the methanol gets pumped in to the machine, there's a breeze of pipe around the back of the machine which goes up into that window there. And then that enables the methanol fumes to be taken outside of the building rather than coming back into the area where we're breathing. The machine has to be vented, otherwise it would just build up pressure in there. And that vent is permanently open. There's no valve in the vent. We've also got the sight glass in this one closed, and we keep that closed for most of the process, and then that stops contamination from getting back into the tank. I'll just give you a hand here, so that tilt this. We need to put the lid on that drum. Take that apart. Put that put it over there on the floor. That's correct. That is then connected onto this bit of pipework in preparation for the next part of the process. Okay. Yeah, let's shut the clamps. So the next thing we're going to do is to add the sodium hydroxide or potassium hydroxide catalyst to methanol. And we're going to mix that up with the hand mixer. And we're also going to agitate it from below with the diaphragm pump. So we've already connected the inlet of the diaphragm pump to the top of this tank. And what that does is that when this is connected onto that pipe there, with that one, that goes to the middle. That's great. So if we follow the flow, we're actually going to be pumping air from the top of this tank. The air is going to come along here. There's a valve here, actually open. The air is going to come along here. The air is coming down here into this, through that valve there, up through the tank. These valves will shut off, and then it's going to come down here and into the bottom of the tank there. So we're actually pumping stale air from the top of the tank rather than air from the surroundings. That's because the air that's in here has got quite a bit of water vapour in it. It's also got carbon dioxide in it. Both carbon dioxide will react with the catalyst, and the water vapour will spoil the catalyst. Now this is connected on a T-piece to the vent. So a certain amount of air will be drawn backwards and forwards through the vent pipe, but if the vent is long enough, then the air just goes backwards and forwards rather than actually being sucked in from outside. The important thing to remember is you're drawing air from the top of that tank and then pumping it into the bottom of that tank, and that will help the mixing process. It will stop the fitting from blocking off from the bottom there as well, because the granules tend to sink into the bottom of the tank, and if they're not agitated properly, they just stick in the fitting. But we'll look at that again in a minute. Now we've got 25 litres of methanol, and we've got 125 litres of oil. And what we're going to do, don't do a titration at this stage. What we'll do is a mini batch at a slightly later stage. So what we're going to do is add a standard amount of catalyst to the methanol solution. And in this case, we've got 25 litres of methanol. We're going to add 25 grams by 30 grams of catalyst, which we will weigh out in the scales on the table here. So we're on the lab table now. Somewhere there's a black bin with hydroxide. Okay. We're actually going to use potassium hydroxide in this case. It's just simply what I've got back home, which just by chance I had potassium and sodium. I think somebody gave it to me. So,
is it better?
In some cases it's better because the glycerol, the byproduct that's formed, doesn't go solid so easily at cold temperatures. In some cases it's worse because you pay more money for it. It's about twice as expensive as sodium hydroxide, and it's more difficult to handle because it's quite dusty. So when you start agitating it, the dust can make you choke if you breathe it in. The sodium hydroxide comes in a pearl format rather than a flake, and the pearl doesn't have that dust with it because it's all compacted in tiny little round spheres. So I prefer to use the sodium hydroxide, one because it's cheaper, two because it's easier to handle, and then I just paid more attention to the removal of the glycerol to prevent the pipework from getting blocked up with solid glycerol. So one thing we need now is goggles. So use some goggles here. There's a few. These are mine here. I'm just going to grab a pair of gloves down here. Wet. So, let's get some new ones from them. So let's open the lid. Be careful. If we put the lid on just gently like that, it stops any of the moisture or carbon dioxide getting in the short term, just whilst we're using the scales and measuring stuff in. So these are just kitchen scales. There's nothing fancy about them. Not particularly accurate or anything. Cheap and cheerful. Just adjust it by moving it around like that. So put that to 0, just check that it's quickly, and then I'm looking to put in 750. So you can see the markers about there somewhere. What we need to do now is we need to move fairly quickly. We don't want to pause any more than is absolutely necessary, but don't move too quickly either, because if you move too quickly then make mistakes, fall over, and you get dangerous chemicals on you. Make sure that the wrists of your gloves are not kinked or anything like that. Just make sure that the wrists are tight. So if you get a particle of caustic in the gloves, it can damage your hand, damage your fingers. If you feel anything nasty inside your glove, no matter what you're doing, take it off immediately and throw the gloves away and wash your hands. Don't try and reuse the gloves either, because it's just not worth it. So if you get a particle in the glove, take action immediately. need to take the watch off to get better seeing. So we're looking for 750 millilitres. Another thing, there's not one drinks on the table, so you might just get a particle of hydroxide in the drink. Do that way. Here we go. There's a measuring cup there. That's it. So it's under 200. Just under 400. So just under 700. That is 700, yeah. So I've put the lid back on here. It's sealed properly. And we can take that over here. Open the valve to the funnel. I'm going to help by pumping the air through.
Is this
No, I need to hold it. And pour in a little bit at a time, don't pour the whole lot in. A bit more. Okay. I'm going to stop there. And put the container on the top of the floor. Close the valve up. Give it a little mix. Here. So this is pumping air to the bottom of the tank. Also use this mixer here to do the mix. That's all it needs to actually just agitate it slightly at the bottom. And then what we're trying to do more than anything is just to stop the hydroxides from caking together. So you can now go straight ahead and put some more in. Open that valve right up. Spin that handle around quite quickly. What you can do is flick it. So, give it a good flick. I don't know if you can hear it on the camera, but you can actually hear the granules spinning around inside the cone at the bottom there. And that's telling us, you see at this stage, that the oxide's not mixed 100%. Wouldn't expect that anyway. But before we try to mix it 100%, let's put some more granules in. Again, main thing at the moment is just to prevent it all from clumping up.
Yeah, brilliant.
Pour the rest of that in now. So, try and get every last bit in. That's it. Right. Close it down. And flip the mixer. And give it a push. So you can do this one at the same time. So here, just a gentle shove. That's it. That's it. Keep on doing that so you can no longer hear the granules in the bottom. Most of the actual agitation will be on the front bit. Surprising how much thread will be agitated just by a very small amount of air being pumped into the bottom of it. I'll take my goggles off now. The rest of your pipe.
Good doing it?
Yeah, I can't hear the particles on the cone now. Can you hear anything? It does sound like it's all mixed up. How long do you think you've been mixing that for?
Maybe 2
minutes? 2 minutes?
Yeah.
I thought about 4 minutes.
Yeah, is it 4 minutes?
Yeah. So you can expect after 4 minutes for it to be, or 5 minutes for it to be mixed. Yeah. It's not hard work, is it? It's just
Good exercise.
good exercise. It's not like you're moving around ferociously.
Not that bad.
No.
Still need a bit of effort.
Right. It's not as easy as pressing the button.
Oh, absolutely. I think it's kind of quiet.
Quiet.
Yeah, it's not quite down.
Right, so there's no
So
particles
Yeah.
in that anymore. Thank you, right? Right, the next stage is to check that we've got our quantities right. And this is actually a type of titration, and most people will recognise it as doing a mini batch. So we're actually going to do, we're actually going to make a very small batch of biodiesel, and this is to check that oil in here is actually going to react with the solution that we've created in there. So it's a combination of these two here which actually make the actual biodiesel reaction. Which, so this is a really exciting of the process where we're doing the basic reaction. I'm going to try and get 50 millilitres of methoxide out of this tank now. Okay. Normally don't need to use the mixer, you can just open the valve and out it comes. That's a little bit too much. I'm going to pull the excess back into the flat surface. Pull slightly too much back in. do. So that's my methoxide solution there. I'm now going to get a sample of the oil from here. There's actually a procedure for taking samples, which I shall explain. What you do is you first sample, cleans out the pipe open here. So you actually discard that first sample. Put it back into now. So discard that. So it's the next sample that's actually going to use. Now I'm out of this vegetable. Put it into my glass inside of the kettle. And then take this back over here. Connect it up to power supply. Nice and hot. Sample going there. What happens is, what we're going to do, it's going to pour the methoxide into here. And then we're going to pour the 5 times 50 into the top of it, stirring at the same time. And it's important to pour the methanol in first, otherwise you could get the methanol boiling off quite quickly if the methanol is added to the oil. So always add the oil to the methanol, not the other way around. This one. Hundreds. Give it a stir. So we're looking at a 5 times quantity. Another 50. So hopefully that will work. Yeah, I think you need to stir it for a bit more. Check for the temperature on the thermometer as well, so you can see what temperature it is. Exactly 50. So that's it is hot enough to get the reaction. Stir up a little more. You need to observe that for a while, see what happens. What you're looking for is definite change in colour from that sort of orangey colour to black, and a separation of a large layer of orange coloured fluid at the top and a small layer of black coloured fluid at the bottom. That means that the basic biodiesel reaction is occurring as it should do. And, if you zoom in on that on the camera at the moment, looking at it initially, I don't think that we've added enough potassium hydroxide to the methanol to get a reaction, because it's just staying that kind of dirty orange colour. Yeah, the colour change should happen within a couple of minutes. Within 3 minutes, you should see the whole thing going quite a dark colour. I'm fairly sure that this isn't working, which is good in a training session, because we will actually show you the necessity for adding more methoxide to it. So what we're going to do now is to tap off just another 10 millilitres of methoxide and add it to the mixture there and see if that corrects it or not. Let's see. Okay, it's fine. Yeah. So here's another 10 millilitres. So add that in. Generally have to add a bit more. If you're working with potassium hydroxide, you generally have to add a little bit more. You use more of it anyway than if it was sodium hydroxide. So that's another reason for using sodium hydroxide, because actually you have to use less of it. What's going on here? Let's check the temperature. The optimum temperature for it to be working is 60 degrees. But obviously, the longer it's stood around, the more the temperature will drop. So this has gone down to 42 degrees. If it drops in temperature, it means that they're longer to react. What we can do, don't want to wait around too long, is to pour it into the kettle and give it a quick boost. Just to raise the temperature a little bit. And it needs literally about 10 seconds. Don't want to heat it too much, because then a lot of methanol would come off the top of that, which is a bit of a health hazard. sometimes you can see droplets of this one dropping down. But I don't think this is doing that. See tiny little droplets of it, it's just hovering around. I'd say that hasn't reacted yet, so a bit more. So we'll come back to the next tank. And a little bit more, I think it's on. That's it. You can see it's slightly darker.
Yeah.
That looks really promising. That looks much better. Yeah. I'd say that was going to do it now. Immediately there's a different colour. There's a darker orange. It doesn't look like that sort of dirty orange colour that it was before. And then hopefully quite quickly we'll see some separation occurring at the top. We'll see some black globules sinking to the bottom. Yeah, well there's one there. Yeah, there's something sinking. See, stuff's sinking. If you come a bit closer to it, if you look right inside the glass, you see that dark, like dark droplets floating down the inside of the glass. That's the glycerol byproduct forming, which indicates that the reaction is going on.
When you use it in the car, will it give all the deposit from the engine?
It would do if you just left the process like that. But we're going to spend quite a lot of time tomorrow actually cleaning the biodiesel. So what we're doing today is all about reaction, making the actual biodiesel. It's quite crude. It's got a lot of contamination in it. So the whole of what we do tomorrow will be about purifying the biodiesel to make it usable in the car. Anyway, if we didn't do that, it would rot the seals in the engine. It'd have methanol left in it. It'd be corrosive, so if you've got something in your hand, it would burn your hand. So we correct all those problems tomorrow morning on the second day.
Amazing, the van, the old van,
Yeah.
actually can use this without having any problem.
Yeah, but this will work in most cars, not just an old van. It's a much better quality fuel than just using straight vegetable oil. Vegetable oil is thick and viscous. It doesn't spray in the injector nozzles as well as biodiesel does. Biodiesel is very similar quality to normal diesel that you get out of the fuel pump, especially in terms of the spray characteristics that it sprays in the engine. It's definitely something happening there. And what this indicates to us now is that we need to add more of the potassium hydroxide flakes into the top of here at the front. Remember we put that in with the funnel and stirred it and mixed it. So we've mixed in on this. We've added 20 millilitres extra of this sodium potassium methoxide. So because we started off with 50, then that equates to an extra 40%. So we've got to add an extra 40% potassium hydroxide flakes to this solution here to get a proper reaction, which is quite a lot. It's quite a large amount. So 40% of 750. That will be the amount.
75. Is that a bit unusual?
No, that's very normal. It depends on the quality of the oil. So maybe the oil that we're using here is quite high in free fatty acid, which means that it's either been exposed to air, water, or it's been overcooked, so the food's left in the fryer for too long, or the oil's not been changed regularly enough.
So every time we do that, we have to test it properly.
Yeah, unfortunately, yeah. It's a bit time consuming. Okay, so looking for 300. Pour that all in one go this time. Frankie's mixing up the extra 300 grams. You can zoom right in on this layer here. That black layer at the bottom of the sample jar is the glycerol, which is the byproduct of the biodiesel reaction, and it's separated. very distinct colour change. Can you see that? Sounds like it's all mixed up. Yeah. Okay. Alright. Now in theory, we've got the right amount, haven't we? Yeah. But just to be on the safe side, let's check it again. Because what we don't want to do is to add all that oil to there and it to be wrong. So it's a good idea to double check this. Because if we do underestimate the amount of catalyst that we need, we're going to end up with a bit of a horrible mess in that. So let's discard what we've got in here. So before we throw it away, if you put the cap back on and just look at what we've got here, we have got two very distinct layers there. Can you see that? The top layer's gone quite clear, it's a bit bubbly, but the black layer you've got a very nice dark layer of glycerol. So that's what we're looking for. That indicates the biodiesel reaction is going nicely, very nicely indeed. If you use these jam jars, don't be tempted to shake the whole jam jar, because what will happen is that the fluid will pour out of the top of the lid. So if anything, just give it just a gentle swirl like that. But no more than that. Don't get the whole jar and go like that, because it will just pour it out everywhere. Yeah, that's really weird. So what we've done here, we're just double checking that the solution in the mixing tank is the right strength. And initially, I'd say that it's reacting. It's gone that sort of dark orange colour immediately. Yeah, fairly immediately. That's the indicator that we're looking for. If we leave it, it just takes a couple of minutes just to sit back and watch what happens. So the temperature's a little bit low, and what will happen is that the reaction in that tank there will take a little bit longer for that to occur. I always like to get the temperature pretty hot. I always like to get it up to a good 60 degrees in that tank that's just been pumped over. Some of it's actually dependent on the temperature of the methoxide itself. So because it's been freshly made, the temperature in this tank has actually risen to about 24 degrees. So the methoxide certainly wasn't 24 degrees, the methanol wasn't 24 degrees when it went in here. But because we've added the granules, it's actually caused a little bit of a reaction there. And that's what exothermic, it actually generates a little bit of heat inside. So I think with a combination of 75 degrees and 70 degrees, whatever that tank gets to, and 24 degrees. Also, when the oil comes in, it also reacts and creates more temperature as well. So the combination of everything should boost the temperature up to probably about 55 degrees on this particular batch.
What is this packing tube?
That's just for draining the pipework, in case you've got some water in there or something contaminating the pipework. You need to actually drain the whole thing.
So let's turn off. First, what will be smell first?
Just look at the bottom. It's got to come out the bottom. Yep, that's it. And the oil's coming out of there. Up into the pump. Up, across. That's it, yeah. And there's a pump. Yeah. Yeah, stir it, so just flip the handle like you were before. Pumped in about half of the amount of oil, and you can give the stirrer a little bit more of a vigorous stir, and you might need to stand on something to actually get it into the top layer a little bit. So something under there.
It's okay.
You up?
Yeah. Just manage.
That's good, yeah. Just stir it one way and then stir it the other way. That's a bit more effective. So then you can feel the pressure on it. That's it. Yeah. And then stir it back the other way. Back the other way. That's it. Right. And then stir it again. Yeah. And that's all you need to do. That's fine. It's literally just like 1 minute.
Sorry.
And then pump some more oil in, yeah. Keep flicking the top of it. Also keep an eye on the temperature on the temperature gauge.
Loading 40.
Right. I'll give it a good stir again on the top there. I don't know if you can see up here with the camera as well, the vent. You look at the pipe which comes out the top of the machine at the back there, up the window. There's a bit of methanol going up that pipe. And that's quite normal. It just shows that the fluid's getting nice and hot. See that? Don't need to worry about that. Temperature's come up to 50 now, which is good. So it's definitely an acceptable temperature. Albert? Happy? Right. Cheers. these like samples and all this stuff that we put into here. We don't have to waste that. It's got methanol in it, so we can, it's such a small amount, pour it into the Whetman tank through that big fitting at the bottom. Give that one, yeah, that's it. Give it a quick stir and pour it back in here. You don't have to stir it for very long. It's only probably 5 minutes at most. And we'll use that sample point again now to confirm that the reaction's taking place. So I'm expecting to see it coming out of here nice and dark like before. Yeah. Does look good. Should really discard the first sample, like I explained earlier. Just pour that straight back in. So this is our proper sample here. Put it on. Sit on the bench. There's no problem there. See a little bit black in the bottom of the jar. Tilting like that. Yes, it's really good. So there's our basic biodiesel reaction. Biodiesel, you can see the top of it as clear. Glycerol forms at the bottom and the top of it goes
Doesn't smell like diesel.
yeah, it'll just smell like methanol, quite a strong methanol smell. That's why we keep the top on it. Breathe that in. We'll let that settle for an hour, then we'll drain the glycerol off. Right, we've left the biodiesel reactants here to stand for exactly 1 hour, and it's now time to drain off the glycerol. And with this top here, put the pipe into the container and open the bottom valve. And, you can see it coming out really black there. That's the glycerol. It's exactly what we saw in the sample jar earlier. So keep an eye on the level on the tank here that doesn't overflow. It's just coming up to 7 degrees ABS. And then we're looking at the colour here as well, just to check that that doesn't go to the red colour, which will indicate that biodiesel's coming through. I expect to get about 15%. There we go. Oh. Yeah, that's biodiesel, and that's the glycerol. I don't know if you can see that on the camera, can you?
Yeah, that's how you can tell it.
So we'll just leave that now for this evening and come back again tomorrow morning.
Okay.
There'll be a little bit more glycerol to drain off in the morning.